All right, so the first thing we need to do is make sure that we have a correctly written balanced equation. What makes this one a little more difficult is that we have to keep track of the water molecules that are going to be attached to these ionic compounds. This is not something that we talked about much, but hydrates, we did do a lab on hydrates, didn't we? Yeah. So these are hydrates. These are hydrates. So in the crystal themselves, they have water. All right. Zinc. Okay. Now, let me give you a clue. The product is going to be a tetrahydrate, which means that the rest of the thing is going to be aqueous, and then there will be some leftover water. How much water? Well, that's what we're going to have to figure out. That's what we need to figure out. First of all, what we need is a solubility chart that I gave you guys. If you're honors, I didn't give you a solubility chart. I would have expected you to memorize. So what are our possibilities here? Sodium is going to go with who? Sodium's going to have to go with who in order to trade partners? And what is C2H3O2? Anybody remember? Acetate. Sodium is what charge? +1. Acetate is what charge? Nope. -1. Okay, so that is a correct formula. Is that going to be dissolved? Well, all sodiums dissolve. All of them. All alkalis are aqueous. All of them. So that's easy. So that means the other pairing is the one that we're looking for. So what's going to be the solid? Raise your hand. This is the other possibility. Thank you, Steve. Zinc what? And is that a correct formula? What is the correct formula? Very nice. Good job. So are both of these formulas correct? Think so. Now, we have to balance it. Water is a part of this, but let's wait on water. Let me explain to you why when we get there. Let's assume that water is not a part of this, and let's balance. How many sodiums on the left? How many sodiums on the right? 1. So how many, what do we need to put in front? How many PO4s on the left? How many PO4s on the right? Okay, so we can't have that. And that, of course, messes up our sodiums. How many sodiums do we have on the left now? 6. How many do we need on the right? How many ZNs do we have on the left? 1. How many ZNs do we have on the right? Well, we got to fix that. How many acetates, C2H3O2s, do we have on the left? How many acetates do you have on the right? That one's good, right? Okay, so we have now balanced it for zinc, phosphate, sodium, and acetate, right? Now we need to balance it for waters. If we have 2 of these things, how many waters do we have there? And how many waters would we have here? For a total of? If we have 4 right here, how many leftover waters? How many waters will this reaction give us? If 4 we need for zinc phosphate, how many will be left over? Question number 2. Of these 2 products, which one is the precipitate? Precipitate. Who remembers what a precipitate is? Nobody. Boy, you need a lot of quiz questions on this. Yes, Reed. The solid. So the answer is? Give me the total formula. In Greek, a dot means plus. Keep in mind that some of these things go so far back that that's back when the Greek language was the international language. All right, so that is your precipitate. That is the one that is your solid. Number 3, we need to figure out, this is not something that I got into with you guys, but I did get into with honors chemistry. We need to figure out how much zinc phosphate will be made. I did teach you how to do mass-to-mass questions. So let's do one of these mass-to-mass questions together, and then I'll let you do the other one by yourself. 2.19 grams of zinc acetate dihydrate is going to be used. I need to find out how many grams of zinc phosphate tetrahydrate that will make. So the first thing we need to do is go to the exchange office. And in the exchange office, we can exchange all our grams of C2H3O2.2H2O for what unit that is internationally recognized? The mole. And the little blue-haired lady will always tell you, I will give you how many moles? 1 mole for the... Okay, what makes this one a little tough is the fact that we have to factor in the 2 waters. So I need somebody to do some adding for me. Zinc is 65.4, and we have 2, and we have 1 of those, and we have 2 times 2 carbons at a price of 12.0, and we have 3 times 2 hydrogens at a price of 1.0, and we have 2 times 2 oxygens at a price of 16.0. All right, go. So this is 65.4. 2 times 2 is 4 times 12. 3 times 2 times 1. 2 times 2 plus 16 times 16. What is 65.4 plus 6 plus 48 plus 6.0 plus 64? Okay, so now we need to convert all our moles of zinc acetate to moles of zinc phosphate. Where do we look for that? In the balanced equation. What does the balanced equation tell us? How many zinc acetates? 3 will make how many zinc phosphates? 1. Okay. So now we have it in terms of moles of zinc phosphate. Dot 4 waters. We need grams of that. So who do we return to? The blue-haired lady, who will always give us how many moles? For the, okay, so you're going to have to do it again. 65.4 times 3. Phosphorus is 31 times 2. Oxygen is 16. Times 8. You know what? We made a mistake. It was maybe not. Did you factor in, Maisie, the 2 waters to get 183.4? No, this should be 2 times water is 18. So 2 times 18 is, what is it? Well, yeah, plus 183.4. So this is 219.4. Everyone figure out what the other one is. 18 times 4. Those of you who are just sitting there staring off into space, this is for a grade, what we're doing. Who's got it? Believe that's right. All right, so 2.19 divided by 219.4. Hit enter. Divide by 3. Hit enter. Multiply by 458.2. Hit enter. One more digit. That is a possibility. The problem is we have another reactant that's at work here, and that is sodium phosphate. Sodium phosphate could give us an answer which is actually smaller, which is the actual answer. Without working both of these out, there's no way to know for sure. So let's continue. So let's do another train track. 2.70 grams of Na3PO4.12H2O. And we've got to convert to moles. And then we got to convert moles to moles of what we got last time. At least this part is going to be the same. That is 1. And then this last part is going to be exactly the same. And what did we get for this last part? What is it? 400 and... All right, so let's fill in everything else. What did the blue-haired lady told us about the number of moles? 1. And Na3PO4, according to the balanced equation, should have a 2, right? We need to figure out what the mass is on Na3PO4. 3 times 23. So let's figure this out. I'm actually recording, so you'll have to tell me whatever you want to tell me later. So the answer is going to be 1.52. 1.52 is your answer to number 3 because it is the smallest one, 1.52 grams. Number 4, your limiting reactant, of course, will be the zinc acetate. And your excess is the sodium phosphate. So I hope that helps you all. We're done.